EM extraction is a very useful concept in microwave office. The idea of it is you have a schematic, as you see here, an example of just a simple filter, and its layout, which you see here, you wish to send for EM simulation to Axiom. You can do that manually, or with extraction flow, what you do is you set it up where if I check this extract block, the red shapes are going to be sent to the EM simulator. I right-click, add extraction, and in this case, with the EM filter being the name of the extracted project, you can see it's ready to be run in Axiom with the ports added. The results are brought back in, and the results updated in the graphs. That's the standard extraction flow. In the new EM planar course that we've developed, we go into more advanced settings. Let me show you one of these here that's very useful. It's called static extraction as opposed to normal dynamic extraction. Now, by static extraction, what we mean is we're going to extract the layout as before to Axiom, but then in that layout, I can go ahead and add shapes, change simulation settings, grid mesh settings, for example. It will simulate, but I am not overwriting that layout every time I run the simulation, which would happen in normal extraction. So we're all ready to do this. We're going to extract to EM filter with ground, the name of the project. And the key for a static extraction is under the extract block properties. If we go ahead and open this up, notice that under parameters, it's a secondary setting. Create shapes has been set to no. The default on that is yes. So we only extract the layout once, and then we go over to the layout. And notice here I've added a guard ring and a couple via blocks. I didn't want these to be put into the normal schematic layout as I'd have to deal with them when I actually create the layout of the circuit, but I do want to see if they have an effect on the simulation. So, in conclusion, with static extraction, I can actually very conveniently modify my Axiom layout without having to interfere with the original extraction process, which would be overwriting every time I tried to change anything. Let's take a look at the results to see if the guard ring made a difference. We're looking at the S11, the reflection loss here. So first of all, here are the measured results from 15 to 30 gigahertz. Here is actually just using modeled elements, no EM. You can see there's quite a difference in the depth of the suck out and the positioning of it. Here is using Axiom, and you can see it agrees with the measured results much better as opposed to the model. Did the side ground make much of a difference? I enable it. It's virtually on top of the Axiom results without the side ground. So I, as the designer, have more confidence that that side ground is not interfering with the filter.